Hi, this is Dave Johnson with another edition of Math Off Topics. And this is part two of a three-part series. Part one was square root conjugates, and I will include a link to that video in the notes below. This being part two is cube root conjugates, and then part three will be the trig conjugates. So let's get into it. So I have in mind doing this limit as h goes to 0 of 1 over h times the quantity cube root of x plus h minus the cube root of x. And you might recognize that as the limit that you would get if you were taking the derivative of, say, the cube root of x. Um, this is probably, I would say, the easiest example of a cube root conjugate problem. But this will illustrate everything that we need to illustrate. And then once you understand this, you'll be able to do any of these cube root conjugate problems. So uh, you might say, well, why not just do what we did with the square root conjugates, multiply top and bottom by um, a plus b, if we think of this as a minus b, okay. And by the way, I should mention this is going to be indeterminate. If h is 0, then you have uh, cube root of x minus cube root of x upstairs, so that's 0. And then downstairs, of course, h is 0, so 0 divided by 0. So we have to do some more algebra here. And that's why we're looking at this possibility of using a conjugate method. So a minus b, and you might say, well, why not just do a plus b? Well, if you try that, you'll get a squared minus b squared, but if you square the cube root, it doesn't get rid of the radical. And that's the big problem here. You want to get rid of the radicals if possible. So we want to multiply by something that is going to end up getting rid of the radicals, the cube root radicals in this case. So I'm going to remind you, if we think about, so a cubed minus b cubed, because that's really what we want to do. We want to cube those radicals, right? If you cube the cube roots, you get rid of the radical cube roots. And so, what is the difference of cubes? Well, remember from your algebra sometime in the past, right? So it's going to be a minus b times a squared plus ab plus b squared. And just for reference purposes, remember that a squared minus b squared, so this is the difference of squares, is a minus b times a plus b. And so what we did in the first video, the first conjugate video, was multiply top and bottom by a plus b. And that would work if you have square root radicals. But if you have cube root radicals, it won't work. It simply will not do what you want it to do. And the reason I make a fuss about this is I've been teaching calculus for a long time. And whenever students run into this problem, they don't know what to do, partly because they don't remember their difference of cubes, but also they assume that the square root conjugate method will work, and it doesn't work. So I have to remind them that this isn't going to work. So now, if I use the difference of cubes, what is a squared plus ab plus b squared? Well, let's work this out. So a squared is, and let me just write this using uh, powers instead of radical notation. So we get a, which is x plus h to the 1/3 times, so squared, so we get actually x plus h to the 2/3 power. AB is x plus h to the 1/3 times b, which is x to the 1/3, and then b squared is x to the 2/3. Okay, so let's let me make a copy of this. Pull this down here, and let's start expanding this. So if I multiply top and bottom by the a squared plus ab plus b squared, so times the a squared, which is x plus h to the 2/3, plus ab, which is x plus h to the 1/3 times x to the 1/3, plus x to the 2/3. And we have to do that downstairs also. So x plus h to the 2/3 plus x plus h to the 1/3 times x to the 1/3 plus x to the 2/3. Okay. Uh, Now, if this was a minus b, then this is going to be a squared plus ab plus b squared. Okay, so that's your, when you multiply that out, you get the a cubed minus b cubed. So let me do that. So limit as h goes to 0, the 1 over h doesn't move. And now upstairs, we're going to have the a cubed minus b cubed. Well, a cubed is just x plus h minus, and then b cubed is just your x. And then downstairs, we have to rewrite what we multiplied by. So we get x plus h to the 2/3 plus x plus h to the 1/3 times x to the 1/3 plus x to the 2/3. Okay. Now, exactly what we wanted to happen happens upstairs. We got rid of the radicals. And the reason we needed to do that is because otherwise we'd have an indeterminate form. A minus b is 0. We don't want a 0 upstairs because we've still got the 0 downstairs and it would still be indeterminate. But now the x's cancel. So we have an h upstairs. Let me go ahead and write this, show every step. So limit as h goes to 0 of 1 over h. And we still have our h upstairs. But downstairs, we have, and this is, I know it's nasty, but we got to write it. So x plus h to the 2/3 plus x plus h to the 1/3 times x to the 1/3 plus x to the 2/3. And now we can cancel the h's. So it was indeterminate before, but because the h's cancel, it's no longer indeterminate. And a very nice thing happens now. So if h is 0 downstairs, well, those are zeros. So you get x to the 2/3. So let me write that. So 1 over um, x to the 2/3 plus x to the 1/3 times x to the 1/3, which is x to the 2/3, plus, and then x to the 2/3. And so you get 1 over 3 times x to the 2/3. And Another way to write that would be 1/3 times x to the negative 2/3. And that's a nice way to write it if you're either way, whether you're just doing a limit or if you're doing the derivative when you get to that point in the course. And so that's our answer. And uh, so you can see that the cube root conjugate is a little different, but you just have to remember your difference of cubes. So memorize that formula and then apply it when necessary. So I hope this was helpful. And if so, if you haven't already, subscribe to my page and give this video a like. I always appreciate that. And so I'll see you in part 3.